In today's video, we're going to look at the terms speed and velocity, and see how we can calculate each of them. As we saw in a previous video, quantities can be of two types: scalar or vector. Scalar quantities only have a magnitude, which is the size or extent of something, whereas vector quantities have both a magnitude and a direction. So speed would be considered a scalar quantity because it only conveys magnitude. This might be a person running at 4 meters per second, or a plane flying at 250 meters per second. Velocity, on the other hand, is a vector because it also has direction, like a person cycling 6 meters per second east, or a train traveling backwards at 55 meters per second. It's really common in the exams to get speed and velocity confused, so just make sure you're completely sure about which one's which, and try not to get them mixed up. Another pair of quantities you need to know are distance and displacement. Distance is a scalar, as it only gives magnitude, like 10 meters or 40 miles. Displacement, though, is a vector, as it has direction as well. For example, a person running 40 meters east, or a ball that falls 2 meters downwards. To help us understand this difference, let's imagine that we have a train traveling across a bridge. The bridge is 550 meters long, and it takes the train 10 seconds to cross it. To calculate the speed of the train, we need to take the distance it traveled and divide it by the time that it took. So 550 meters over 10 seconds, which gives us the scalar quantity of 55 meters per second. If we took this same equation, but replaced the scalar quantity of distance traveled with the vector quantity of displacement, we'd then be able to get the vector quantity of velocity. If we knew the direction that the train was traveling in, for example, east, then instead of writing the distance, we could write the displacement, which would be 550 meters east. The time would still be 10 seconds, and the velocity would still have a value of 55. But the units of the velocity would be meters per second east, rather than just meters per second, like we've got for speed. Now, the symbol formulas for these two equations can be kind of confusing, because they use the letter S to represent different things. For velocity, the S refers to the displacement, but in the speed equation, the S stands for speed, and the D is distance. In both cases, though, the T stands for time. In reality, people often use the velocity equation regardless of whether they've actually got a direction or not. The benefit of using velocity is that you can have a negative velocity to represent going backwards. Now, often objects don't actually move at a constant speed, but instead vary along their journey. We can still use this equation, but we need to divide the total distance or displacement by the total time that the journey took. And the value that we calculate will then be the average speed or average velocity. To give you an idea of real-life speeds in meters per second, people walk at about 1.5 meters per second, run at around 3 meters per second, and cycle about 6 meters per second. All of these numbers do of course vary a lot though, depending on the age and health of the individual, and how much effort they're putting in at the time. Then for vehicles, a car on the main road might travel around 25 meters per second, while a fast train could travel 55 meters per second, and planes can exceed 250 meters per second. It's not only the speed of objects that varies though. As we'll see in a later video, Sound waves travel at 330 meters per second when they're in air, which is a figure that you need to remember. But when they're traveling through different mediums, like water, their speed changes. A more relatable example is the wind, which is just the natural movement of air. This can vary from almost 0 meters per second on a still day to faster than a speeding train on a windy day, and can be affected by things like temperature, atmospheric pressure, and these structures it's traveling past, like buildings or mountains. Anyways, that's everything for this video. So hope you enjoyed it, and I'll see you next time.